Hi, everybody. Thank you for joining me. A very happy Friday to you. Today is a catch-up day, and we are going to review and preview exponents. So our daily agenda is to complete a two-step equation, which is a review from yesterday. I'm going to ask you to please download the Kami extension, and then we're going to do 3 steps to complete today's activity. The first will be to complete any makeup work you owe in Unit 2. The second will be to review the laws of exponents. And then the third will be to preview 2 new laws of exponents. So your homework is to complete this Google Slides and submit what you do not complete in class. So the first thing we're going to do is we're going to solve this equation. So to solve this equation, I would like you to please write your game plan. So your game plan is actually the steps that you're going to use to solve the equation in the order that you're going to use them. So I'm going to write the GP. And so the first thing I want to do is undo my subtraction by adding 7 to both sides. And then I want to undo my multiplication by dividing both sides by 8. So I'm going to ask you to please draw your line, because that divides the equation in half, and it reminds you whatever you do on one side of the equation, you have to do the same thing on the other side. So our game plan tells us to first add 7 to both sides of the equation. And you'll notice that I'm lining it right up under the -7, and on the right-hand side, right under the 25. So 25 plus 7 is 32. Now, I have opposites. So -7 and 7 cancel out. And the only thing I'm left with is an 8x. So I'm going to write that down. Sorry about that. So we have an 8x equals 32. So now I'm going to divide both sides by 8. And I get an answer that x equals 4. So I can pick up x in my original equation and substitute it in. So now I'm going to do my check. So 8 times x, and I know x is 4, so I'm going to write 8 times 4 minus 7. And I know that the product of 8 and 4 is 32. And now I'm going to subtract 7, so I get an answer of 25. And if I look on the right-hand side of the equation, that is what it is supposed to equal. So this equation checks. And I know I've correctly solved the equation. All right, so now we're going to go on, and I'm going to ask you to stop the video and to download the Chrome extension Kami. When you're done, you can restart the video, please. Now we're going to look at our 3 steps that we need to complete today, and that is to make up any work that you owe for Unit 2 and submit that, then to review the laws of exponents, and to preview the last 2 laws of exponents that we'll be looking at formally on Monday. So the first step is to please go on to onto Aspen, and there are 3 assignments: the diagnostic arena, the power of a power, and multiplying exponents. Now, I just assigned multiplying exponents, so everybody's going to need to complete that. I'm going to ask you to look for a mastery level of 80% or above, and if you get 80 or above, you will get 100% credit for the homework. And then the fourth assignment is a quizzes activity, and it is on the division of exponents. So if you would take a second and just write down any work that you owe according to Aspen. And then I'm going to ask you to complete that work during class. The second step is our review time. And so we're going to try 6 problems and a word problem to review the laws of exponents that we have looked at so far. Okay, so our first problem, we are multiplying in bases of the same. So I want to remind you, when you are multiplying in bases of the same, you want to add the exponents. So we're going to do x to the 9 plus 5, and I'll write it here. And 9 plus 5 is 14. So our answer is x to the 14th power. I'm going to try to write that a little neater for you. All right. So example 2, we're taking the power of a power, which means we multiply the exponents. And 9 times 5 is 45. So our answer is x to the 45th power. The third example, we're dividing in bases of the same. I want to remind you, you divide where the larger exponent is. So in this case, the larger exponent of 9 is in the numerator. So I'm going to bring this up. And I'm going to divide by 5. So x to the 9 divided by 5 is x to the 4th power. All right. On the example number 4, the larger exponent happens to be in the denominator. So I'm going to actually bring this down, and I'm going to divide in the denominator. So I have nothing in the numerator. And remember, if you don't see a number, it is the phantom 1. And x to the 7th power minus 3 is x to the 4th power. On the next problem, we are multiplying in bases of the same, and there are also some coefficients, and those are the numbers that are multiplying the variable. So I'm going to rearrange the order, and I'm going to take 2 times 4. And remember, we can do this because of the commutative property of multiplication. And then I have x to the 9th power times x. So please remember, if you don't see an exponent, it's the phantom 1, so you can write that down. And I know the product of 2 and 4 is 8. And then x to the 9 plus 1 is x to the 10th power. And that would be my final answer. All right. On the last problem, we're going to do the same thing. We're going to organize the numbers together and the variables. And I want to remind you, we can do this by the commutative property of multiplication, which says when you're multiplying, order doesn't matter. All right, I can look at 10/15 and simplify that fraction because the greatest common factor is 5. So 5 times 2 is 10, and 5 times 3 is 15. So the first part of this answer is 2/3. Now, the next step is to take care of the variables, and I know that in the numerator, 6 is larger than 5, so I'm going to subtract in the numerator, and x to the 6 minus 5 is just a 1x. So the answer in this case would be 2/3 x. All right, the last problem that we're going to look at is a word problem. So again, we are on the last part of our review time. So a lab technician draws a sample of blood. A cubic millimeter of blood contains 22 cubed white blood cells and 22 to the 5th power red blood cells. What is the ratio of white blood cells to red blood cells? Well, we need to remember that a ratio is a comparison of two numbers using division. So I'm going to write my ratio in words first. And so in words, I am taking the ratio of white blood cells to red blood cells. All right. So I know that there are 22 cubed. Oh, sorry about that. Let me fix that. It's a little messy. White blood cells, and then the number of red blood cells is 22 to the 5th power. So we're dividing in bases of the same, so we're going to do our subtraction where the larger exponent is. Since 5 is greater than 3, we're going to actually subtract in the denominator. So I'm going to bring this down and subtract 3. So if we don't see a number in the numerator, remember it would be the phantom 1. And then fraction bar, and 25 to the 5 minus 3 power is 25 squared. Okay, so the last part of this lesson today is the preview lesson. So I want you to study these examples below and think about what you notice. So 9 to the 0 power is 1. 1/2 to the 0 power is 1. 75 hundredths to the 0 power is 1. And 962 to the 0 power is 1. So a non-zero base raised to a power of 0 always equals 1. All right. So next we are going to look at our next big idea, which is a preview, which means we're going to formally look at this on Monday. So please do watch the video about negative exponents and study the table below. And then we're going to try to make some generalizations. You may need to turn your video off to watch this. You may need to stop the video to watch what I have embedded in here. And this is by Mashup Math, and it's on the exponent rules. So when you have negative exponents, I want you to look for a pattern using the powers of 2. So you can literally see that as we multiply by another power of 2, we are adding another power 2 here, another factor. So to go in the other direction, 8 divided by 4 is 2. 4 divided by 2 is 2. 2 divided by 1 is 2. 1 divided by 2 is a half. A half of a half is a fourth. And a eighth of a fourth is fine. You'll get credit. So remember, to flip a fraction, it means to take the reciprocal and change the sign of the exponent to positive. So I always remind students, everybody wants to be positive, just like exponents. So you flip it or take the reciprocal and change the sign of the exponent to make it positive. All right, so what I'm going to ask you to do now is to submit this Google Slides, and you have completed your work for the day. Thank you for working so hard, and I wish you a wonderful weekend.